Hi, and welcome to Duality. My name is Omer, and today I'll show you how Duality enables secure federated learning for multi-institutional oncology research. The main challenge in this space is the need to analyze large digital pathology datasets distributed across multiple institutions. Research labs often seek to optimize their models, such as cancer detection models, but require access to vast amounts of data. However, medical data is highly sensitive, and strict regulations prevent it from being shared across institutions. Additionally, pathology images are extremely large, making centralized data processing impractical. Duality's private federated learning integrates with a trusted execution environment, ensuring that data never leaves its organization. This approach maintains security and compliance with regulatory constraints. With our solution, training occurs locally at each institution's site. Instead of sharing raw data, only the locally computed model updates are exchanged and aggregated. This iterative process continues until the model converges, ultimately delivering the final trained model to the intended recipient. In this demo, we will train a CLAM model using our federated learning platform. The dataset comes from two participating medical centers. The first medical center defines the workload, including the code and pre-processing steps required for training. This workload is then distributed to the second medical center. Each institution trains the model locally on its data and computes local weight updates. The first medical center aggregates these updates after each epoch. Finally, the trained model and accuracy report are received by the first medical center. Note, in this demo, the aggregation takes place at the first medical center. However, the Duality platform offers flexibility, allowing you to determine where each component is deployed based on your specific needs. Now, let's see how this works on our platform. First, we'll navigate to the Assets tab, where we can see that I have added two SVS data assets to the platform and associated them with the WSI test project. Next, when we drill down into the project, we can see that I am representing the first medical center, and this project includes two participants. I have the roles of session initiator and analyzing party, meaning I am entitled to receive the results. I also have the asset owner role, allowing me to add data to the project, and the compute owner, which means the aggregation will take place in my side. The second participant is strictly an asset owner. To start the session, we will run a notebook that executes all relevant actions. On the first step, we connect to the platform and import the necessary libraries. Once logged in, we can view the participants and their datasets. Both participants provide datasets labeled WSI and WSI test. These datasets will be used for model training. On the second step, we now configure the participants and their assets. We select the ESI dataset from each of the participants. Next, we are going to configure the session input training parameters and hyperparameters, such as creating image patches, extracting features, splitting data, and executing the training process. Once everything is configured, we start the session. After all configuration is made, we are ready to initiate the session. We can now switch to the platform to monitor its progress. Once session completes, we can view the result metrics, including the AUC, test accuracy, and test loss. The results shown in this demo may have lower accuracy due to the limited data volume, however. In our testing, when comparing federated learning to training on a single dataset, we consistently observe a clear advantage. Federated learning enables better model generalization and improved performance across diverse data sources. The federated approach outperforms single-site training. Single-site training often leads to overfitting, evident in the validation and training loss metrics, which indicate missing data records. With Duality's federated learning platform, researchers can train high-performing models while maintaining data privacy, security, and regulatory compliance. Thank you for watching.